Let's talk about the law of homogeneity. It states that for an equation relating physical quantities to be valid, the left side and right side must have the exact same dimensions. Also, the dimensions of quantities being added or subtracted must be the same. What does this law mean? Let's have an example. If we have the equation velocity equals initial velocity plus acceleration times time, it means that the dimensions of quantities being added or subtracted must be the same. It means that the dimensions of velocity must be the same with the dimensions of initial velocity and the dimensions of this last part, acceleration times time. So we have to establish the dimensions of velocity, and initial velocity in this case will have the same dimensions as final velocity because they're the same quantity. With that in mind, let's get into it. So we want to check whether the equation V equals U plus AT is valid using the law of homogeneity. So what are the dimensions of velocity? We know that velocity is equal to displacement over time. Displacement being length, so we replace it with L, and t being time, so we replace it with t. So the dimensions of velocity are L over t, or Lt negative 1. This format is useful in certain cases, but in this case we'll maintain L over t. So that's L over t is equal to the dimensions of initial velocity are also L over t. Now we get to acceleration. Acceleration is equal to velocity over time. We know the dimensions of velocity, which is Lt negative 1. So that's Lt negative 1 over the dimensions of time is t. This becomes Lt negative 2. Or it can also be L over t squared. Depends on which one you want to use. So in this case, let's use L over t squared. So the dimensions of acceleration are L over t squared. And the dimensions of time, simply t. So this is L over t is equal to L over t plus, we cancel one t here and this t. We are left with L over t. From the law of homogeneity, an equation to be valid or for them to be added or subtracted, each term must have the same dimensions. Let's use this law to verify another equation. The equation we're going to use is S equals ut plus half at squared. The dimensions of S is length, so that's simply L. The dimensions of velocity was L over t, and the dimensions of time were t. Plus, when we're dealing with dimensional analysis, we can ignore the constant, so we go ahead and put acceleration. Acceleration was L over t squared, and then time was also t, but it's t squared, so that's t to the power 2. We can cancel t and t here. We can cancel t squared and t squared, leaving us with L equals, here we're left with L, and on the last part we're left with L. By the law of homogeneity, for an equation to be considered valid, each term must have the same dimensions if we're adding them or subtracting them.